Okay, so question 4, we'll do a few power questions for our shafts that is rotating around. So we're looking at the power and the torque relationship here. So if we start off with that, we know that power equals doing a certain amount of energy over a period of time. So it's the rate of doing energy, it's power. Can you write out what the proof is for that power equals torque times by the angular velocity? So I think this is where I'd like you to have a pause of the video and see if you can go from energy divided by time and work out how you can get from there to torque times by angular velocity. And maybe you might need a bit more hints. So if you need a bit more hints, let's see another line, then pause it and see if you can work it out from that position, okay? So if you're stuck at this position, let me give you the first hint. The first hint is going to be that energy is force times distance. Okay. So does that give you any clue? Can you work it out from that line now? Can you see any way through to, looks like distance divided by time? Well, that's obviously velocity, and we want angular velocity, so maybe that helps. If not, press the next line. Well, indeed, distance divided by time, that's velocity. So we've got force times velocity. It could be the rate of or way of measuring power for a machine of some kind. But we have got torque and angular velocity. So how can we go from force times velocity to torque times angular velocity? Well, to do this, we'll introduce a position on the outer part of the shaft, which would be the radius. And we'll say that the force is being applied on the outer part of the shaft. So it's force times the radius, which of course is torque. And so if I've got an R here, and then if I divide by an R, then my R's cancel and we end up with the previous line. So here we've got velocity divided by R. What's the definition of velocity divided by radius? That's angular velocity. So that's our proof. So we've got torque times angular velocity is, well, that's the symbols. Okay. And don't forget that the angular velocity will be something that we measure in radians per second. Okay. Next, let's look at some RPM and angular velocity calculations. What is the RPM of the Earth going around the Sun? Okay, what's the RPM of the Earth going around the Sun? Right. So we go around the Sun once every year. So we do one revolution once every year. So does that tell us how you can solve that problem? Okay, I'll show you the answer if you have worked it out. So we're doing one revolution once every year, and every year will have 365 days in it. So each day will have 24 hours in it. and each hour will have 60 minutes in it. So we're doing RPM. So don't forget RPM stands for revolutions per minute. So we want to take it down to minutes here. So the RPM is going to be 1.9 times 10 to the minus 6 RPM. So notice that the units here is RPM, not hertz or something like that. Next, given that we know that what the RPM of the Earth going around the Sun is, what's the angular velocity going to be then? Okay. Angular velocity. For this, we will take how to convert RPM into angular velocity. We'll rewrite it that way around. So we are looking for angular velocity, so that must mean when we take the RPM, we want to divide it by 60. So that would be per second. So that becomes even smaller. But then we multiply it by 2 pi, so it moves it up a little bit. But overall, it's going to make it a smaller number. So the angular velocity will be our RPM value. Let's divide it by 60 to make it in seconds, and multiply it by 2 pi to make it into radians. So angular velocity is radians per second. So we get a smaller number there. We've dropped down by almost 10, haven't we? Right, so let's come back to doing some shaft problems, or one shaft problem, and then we're done. So here we have got a shaft spinning at 5,000 revs per minute. So it's doing 5,000 RPM. It's transmitting a power of 30 kilowatts. What is the torque experienced in the shaft? So we're going to use the equation power equals torque times by angular velocity. And to convert our RPM into angular velocity, we'd use 2 pi divided by 60. Hopefully that's enough information there for you to pause the video to work out one of the answers, and once you think you've got one, press play. So you should have got that, that the answer is 57. So hopefully that was straightforward. We've got the torque there, so the 30,000, that will be my torque. And I've got my 5,000, which I'm going to multiply by 2 pi divided by 60. So putting all of them into your calculator, you should then get 57.3. And okay, sorry, what's the torque here? We're given the power. So I'm going to rewrite this equation here, aren't I? So let's do that. So let's rewrite this guy. So that would be torque equals power divided by angular velocity. So the power is 30,000 watts, and the angular velocity will be 2 pi divided by 60, and the RPM is 5,000. So stick that into your calculator, and we should get 57.3 Newton meters. Right, so that's enough torsion type questions. I think that covers that chapter quite well.